how to solve for utility maximization problem. The question is, we have to maximize the utility function, that is u is equal to 1 upon 4 times x raised power 1 upon 3 times y raised power 2 upon 3. X and y are the two goods such that 5x plus 2y is equal to 150. 5 denotes the price of good x, 2 denotes the price of good y, and 150 denotes the income of the consumer. So what we want to do in this question is that, and let me draw the graph first, so it will be pretty nice if I draw a simple graph here. So let us denote good x on the horizontal axis and good y on the vertical axis. The consumer's endeavor is to maximize the utility subject to the budget constraint. And what is the budget constraint that he is facing? This very budget constraint. First, we draw the budget constraint. You can check it out by yourself. It will be like this. So for equilibrium, what happens? For equilibrium, what we need to do? For equilibrium, so with the given budget, consumer wants to reach to the highest possible indifference curve, or he wants to maximize his utility. So for optimum, what will happen? We will draw one indifference curve. Let us say this is IC1. Similarly, we have another indifference curve like this, IC2. So optimal consumption bundle will lie at a point where the slope of the indifference curve is equal to the slope of the budget line. Okay, that is, we should have the marginal rate of substitution between good x and y should be equal to the ratio of the prices, that is price of x upon price of y here. Okay, so what is MRS? MRS is the slope of the indifference curve. What is PX upon PY? This is the slope of the budget constraint. So let us solve for MRS. What is MRS? MRS is simply the ratio of the marginal utility of good x and marginal utility of good y. It should be equal to the price ratio. Price of good x is 5. So let's write it here. 5 upon price of good y is 2 here. Okay, so MUX means marginal utility of good x. Okay, so it is simply the change in the utility due to the change in the consumption of good x divided by what is our marginal utility of good y, means the change in the utility due to the consumption of good y. Okay, and it should be equal to the ratio of the prices 5 upon 2. Solving this, so du upon dx means the partial derivative of the given utility function with respect to x. Okay, here we have x, its derivative will be equal to, so first we have 1 upon 4 times the exponent of x becomes coefficient by power function rule, and x raised power, and the exponent of x will be subtracted by 1. So 1 upon 3 minus 1 becomes minus 2 upon 3, and y raised power 2 upon 3 will remain same because we are taking partials with respect to x. Symmetrically, du upon dy will be equal to, so we have 1 upon 4, the exponent of y becomes coefficient, so we have 2 upon 3, x raised power 1 upon 3 will remain same, and the exponent of y will be subtracted by 1, so 2 upon 3 minus 1 is minus 1 upon 3, and it should be equal to the ratio of the prices 5 upon 2 here. Okay, that means so let me solve it further. So 1 upon 4 gets cancelled. So here we have 1 upon 3, transposing this, it becomes 3 upon 2. And if I transpose this x to denominator, this y to denominator, you can check it out by yourself. It will become y upon x should be equal to 5 upon 2. 5 upon 2. Okay, so here 3 gets cancelled, or we will get y upon 2x is equal to 5 upon 2, which implies y will be equal to 5 upon 2. Transposing this here, it becomes 2x. Okay, 2 and 2 gets cancelled, which gives us y is equal to 5x. Now we plug the value of y is equal to 5x back into the budget constraint. Our budget constraint is here. So here we have the budget constraint to find out the so we have 5x plus 2 times the value of y is 5x again, should be equal to 150. Solving, so we have 5 2s are 10, 10x plus 5x is 15x, 15x is equal to 150, dividing both sides by 15, so we will get x is equal to 15 1s are 15, 15 zeros are 0, so we will get 10 units of good X as the optimal consumption. That's X is equal to 10. To find out the value of Y, plug the value of X is equal to 10 in this equation. That gives us Y will be equal to 5 times 10, which comes out to be 50. Okay, that means consumer will consume 50 units of good Y and 10 units of good X. And we can also find out the corresponding what we call the utility derived from the consumption of good X and Y. We simply plug the value of X is equal to 10 and Y is equal to 50 back into the utility function. I hope I make myself clear in this video. Thank you.